Hi everyone, I hope that you are having a good evening. I decided to do a recording tonight instead of a live WebEx session, mostly because I'm concerned that my doorbell will be ringing the entire time because it's Halloween. So I'm going to have this posted, and please don't hesitate to contact me during Skype or during office hours if you have any questions. I just thought this would be better than the doorbell ringing and the dog barking throughout the WebEx tonight. So hopefully this will be beneficial to you. I want to talk a little bit about inverse relations and inverse functions. That is what we are starting with in Chapter 5. In the most simplest definition of inverse, what you are looking at in front of you is a relation. So the relation that we're looking at is 2, 4, -1, 3, -2, 0. The way that we get the inverse of that is we reverse the x and the y. So for our first one, since we have 2, 4, the inverse for that is going to be 4, 2. And if you look right here in the blue, we have 2, 4. That is our original relation. The inverse of that is 4, 2. So the definition of an inverse is we take what was the x value, in this situation it's 2, and we put it for the y value. Then we take what was the x or the y value, which in this situation is 4, and we put it as the x value. So our next point that we have is -1, 3. So the inverse of that is going to be 3, -1. So we are simply reversing the x and the y. And you can see this line right here that we have, the dotted line, that's called our identity line. And our inverse is always going to be a reflection across that line. Okay? Our final point here is -2, 0, and when we find the inverse of that, we get 0, -2. Now this situation right here is ordered pairs, and so I want us, and I think the ordered pairs help us to get an idea of really what we're looking at. I want us to look a little closer at some graphs. So the next slide is going to show us a original relation and its inverse. If you look in blue, we have our original relation, and it is a parabola. So in blue, we've got our original relation, y equals x squared minus 5x. And a couple of the things I want us to note is our x values here, those are our domain for our original function. And then our y values here, they are our range. Now when we look at the pink, which is the inverse of that, the inverse of the original relation, I want you to notice the values that were in the domain of my original function are in the range of the inverse. Okay? And the values that were in the range of the original relation is in the domain of the inverse. So our x and our y's are switching. And so here is a graphical representation of an inverse. Now, we can also discuss finding a formula for an inverse. Now, I do want you to be sure that you spend some time looking over the definition of a one-to-one function. One-to-one function. So in your reading, and you know that when I do our WebEx that it's impossible to cover everything for the entire week. So I do want to make a note that you want to look up the definition of a one-to-one function. That is an important concept that you want to be sure that you look into as you move through Chapter 5. So, in order to obtain a formula for an inverse, so this is where we look at it algebraically, what we have been doing graphically. So in order to obtain a formula for a one-to-one function, for its inverse, these are the steps that we are going to follow. The first thing that we are going to do is we are going to replace the f of x with y. The second thing is we are going to interchange the x and the y. So that just means wherever there's an x, we're going to put a y. And wherever there's a y, we're going to put an x. Then the third thing that we are going to do is we are going to solve this new equation for y. Now, this particular step right here, sometimes students have trouble with that. And the reason that they do is sometimes fractions are involved. Now, I do want you to realize the difference between not understanding how to do something, an operation with fractions, versus not understanding how inverses work. So you will be challenged this chapter to review some of your fraction properties. And if you are struggling with solving for y because of some of those fraction operations, don't hesitate to contact me so that I can help with that. So just remember, there's going to be a difference between understanding what an inverse is versus understanding how to do all those operations with fractions. In the past, students have often struggled with those operations with fractions. So please reach out to me if you are finding that you are a student that's struggling with fractions. And as we progress through the chapter, I will do a couple of more problems that involve fractions, just so you can get a review of some of those fractions. So after we solve for y, then our final step is to replace y with f inverse of x. And that is how this is read right here. This is read f inverse of x. F inverse of x. Okay? Okay. So here we have, the first thing that we have to do is we have to determine if the function f of x equals 2x minus 3 is a one-to-one function. And as you review how to determine if something is a one-to-one function, you will be using the horizontal line test. Horizontal line test. And there's some great videos that you have available to you on how on what a one-to-one function is. So definitely be sure to review that. Now, this particular function is a line. F of x equals 2x minus 3. It is a line with a positive slope. Therefore, it is a one-to-one function, and so that means that its inverse is also a function. So we are able to find an inverse function for this. So I am going to go through our steps. So we have f of x equals 2x minus 3. Our first step in finding the inverse of this function is to replace f of x with y. So I am going to rewrite this as y equals 2x minus 3. So all I have done is I have taken out that f of x and I have replaced it with the y. My next step is to replace y with x and replace x with y. So I am going to take my first y and I'm going to make it an x, and then I am going to take my 2x and I'm going to make it 2y. So wherever there was an x, I put a y. Wherever there's a y, I put an x. Okay? Now, my next step is to solve for y. We are now going to solve for y. So I am going to add 3 to both sides. So I am left with x plus 3 equals 2y. And my next step then is to divide by 2. Now I am going to write it to where I have y on the left, and then I have x plus 3 over 2 on the right. Okay? Now one of the things that happens in this particular situation is students want to stop here. They have y equals x plus 3 over 2, and they want to stop. Okay, there is one more step, and that last portion is that we replace the y with f inverse of x. So we read this as f inverse of x equals x plus 3 over 2. Okay, so this is our inverse function, and our original function is right here. F of x equals 2x minus 3. Now, let's take a few minutes and look at what this means. So, on the left, what I have is my original function. This is my original function. Okay, and this is a table of values. These are not all of the values for this line, because a line has infinitely many points. But this is a table of values for my original function. Then here is my inverse function. So, one of the things that I want you to notice is I want us to look at my y-intercept in my original function. My y-intercept, and look at the relationship of my x-intercept in my inverse. So in my original function, one of the points that I have is 0, -3. The definition of an inverse is we switch the x and the y. So this ordered pair for the inverse, 0, -3 in my original, in the inverse is going to be -3, 0. So there is a relationship between the y-intercept in the original and the x-intercept in the inverse. The other thing that I want you to look at in this situation right here is I want you to look at my x values. And remember, the x values represent your domain. And my domain in my original function becomes the range in my inverse. And that is going to be very important as you start solving bigger, longer problems on your homework. So just remember, the domain of the original is the range of the inverse. And the other aspect of that is the range of the original is the domain of my inverse. So it's super important that we remember that relationship. So the domain of the original is the range of the inverse. The range of the original is the domain of the inverse. Okay, so now let's look at these two graphs and we will see how they are in relationship to each other. So our green or teal color, that is our original, and you can see that my x-intercept right here is, my y-intercept is at -3. Then if you look at the inverse, my x-intercept is at -3. Okay, this is called our identity line, y equals x, and my inverse functions are a reflection across that line. Okay, so that is a little bit about inverse functions. So I do want you to be aware that you will start doing some different operations with fractions, and please don't hesitate to let me know if you have trouble with that. So the other major topic this week that we will be talking about is logs. And so I want to take a few minutes now to really kind of dive in and talk about what a log is. So let's look at another inverse. Okay, so what you are looking at right now are two inverses of each other. So my original function that I am talking about is this y equals 2x. This is my original that we're talking about. Okay, this is my original. X equals 2y is the inverse. Now, we do not know how to solve for y in this situation, okay? because we haven't been given the tools to do that yet. And the reason that I like for us to look at that is so that we can understand why we need logs. So my gray graph right here is my original function, and it's y equals 2 to the x. So that means that I am raising 2 to different powers. That's my variable. So I could raise 2 to the negative 1. I could raise 2 to the negative 2. I could raise 2 to the positive 1, positive 2, or any aspect of that. The inverse of that, when we take the inverse of y equals 2 to the x, we have x equals 2 to the y. Now, our properties and what we were told to do is that at this point, when we have x equals 2 to the y, we are supposed to now solve for y. But until we introduce logs, we do not know how to do that. We don't know how to solve for y. So we have to introduce logs. So I want us to take a couple minutes to really kind of wrap our mind around what a log is. Okay? We define y equals log base a of x as that number, y, such that x equals a to the y. Now, our x is always going to be greater than 0. That's just what we are working with. Now, our exponent can be negative, but our base is always going to be positive, and our value is always going to be positive, because if it's not, then we kind of move into complex numbers, and we are not going to be working with complex numbers in this particular class. So here we read log base a of x as the logarithm base a of x. So let's take some time, let's take a few minutes and just wrap our mind around exactly what a logarithm is. So here I've got some examples. Now, eventually you will be using logs and your calculator, but we're not there quite yet. Right now we're just going to focus on how log works. So we aren't going to do these on the calculator. We are going to ask ourselves questions. So the question that I am asking myself for A, so I have log base 10 is 10,000. So the log, what I am looking for is an exponent. So I am going to have equal to right here. So I am asking myself, what do I raise 10 to get 10,000? So I am going to raise 10 to some number. I don't know what that number is, but I am going to say 10 raised to some power is going to equal 10,000. Okay? Now, we may kind of off to the side just kind of be thinking, okay, well, 10 to the second power is 100. Okay, and that's not what I'm looking for. I'm looking for 10,000. So maybe it's 10 to the third power. And 10 to the third power is 1,000. So the answer to this is 10 to the fourth power. That's how I get 10,000. So my answer here is 4. Now, we are going to really be sure that we understand the relationship between an exponent, which is what I have right here, 10 to the fourth power equals 10,000, and my log, which is what I have right here. Log base 10 of 10,000 equals 4. So we really want to start making the connection between the exponent and the log. Okay, so this is an exponential and this is logarithmic. So we want to make that connection between those two. So let's look at our next one. Let's look at our next one, because we can have negative exponents, but we can't have a negative base. Okay, so our next one, we are going smaller. So I'm still talking about base 10. So I've got log base 10 But when I do that, I'm going to get a very small number. So I've got log base 10 of 0.01. So what do I raise 10 to get 1/100th? What power do I raise 10 to get 1/100th? And so this is a situation where you want to think about the definition of negative exponents because we are going to a smaller number. Okay, so you definitely want to have an understanding of what negative exponents mean. And if you need to review that, definitely let me know. Negative exponents. Negative exponents. Whoops. There we go. Negative exponents. So let's say, okay, if I have 10 raised to the -1 power, that is going to give me 0.1 or 10 or 1/10. Okay, so if I raise 10 to the -2, that's when I would get 1/100th. So log base 10 of 1/100th is -2. Okay, and again, look at the relationship between this exponent right here and this log, because you're going to be continually going back and forth with that. Okay, let's do C. So C says log base 2 of 8. Log base 2 of 8. So we are going to ask ourselves, what do I raise 2 to in order to get 8? Okay, and so we may do some work just right over here to the side. And we'll say, okay, well, 2 squared is 4. Okay, and so then we can think 2 to the 3rd is 8. So what do I raise 2 to get 8? So you can think 2 question mark equals 8. And the answer here is 2 to the 3rd. 2 to the 3rd equals 8. So log base 2 of 8 equals 3. Okay, now I am going to trick you. So one of the things that you will also need to review is something called rational exponents or fractions. So now we're looking at D, and it's log base 9 of 3. Log base 9 of 3. So the question that I'm asking myself is, what do I raise 9 to in order to get 3? Now, many people will want us to say 2 because 3 squared is 9. But that is not what this question is asking us. This question is saying 9 raised to what power gives me 3? 9 raised to what power gives me 3? That is what this question is asking. 9 raised to what power gives me 3? It's not asking, what do I raise 3 to in order to get 9? It's saying, what do I raise 9 to? Now, one of the things one student might assume is that because our number is getting smaller, that we need a negative exponent. So a student might say, okay, well, I'm going to say 9 to a negative exponent. So 9 to the -1, that turns into 1 over 9. Okay, so we're not going to be talking about a negative exponent. Now, what you might have realized is that the square root of 9 is equal to 3. The square root of 9 is equal to 3. Now, so what we have to do is we have to remember, well, how do I write square root as an exponent? And the way that we do that is we say 9 to the 1/2. And if you'll remember, 9 raised to the first power, that's what's inside my square root. On the number that's inside the little square root sign is a 2, and that's called an index. So the square root of 9 and 9 to the 1/2 power, that means the same thing. So the square root of 9 and 9 raised to the 1/2 power means the same thing. Now in your Math 093 course, you will have some practice with that. So we might need to review negative exponents and rational exponents. I'm going to write that up here too, rational exponents. And you will have an opportunity to review those in 093. But don't hesitate if you have more questions to let me know. So the answer to this one is 1/2. So anytime that you see a situation that's a square root, just make that connection that square root means an exponent to 1/2. Now you could also have a cubed root. So in C, if I had 8, I could do a cubed root of 8. The cubed root of 8 is 2. So the way that I would write that, that would be written as 8 to the 1/3. And this is definitely going to come up, these rational exponents and these negative exponents, they are going to continue to come up in this chapter. So that definitely is something that you want to get some practice on. Okay, E, let's look at E. So in this situation, we have log base 6 of 1. Log base 6 of 1. So we are asking ourselves, what is it that I raise 6 to in order to get 1? What do I raise 6 to in order to get 1? And in this situation, it's 0. Okay? Because anything raised to the 0 power gives us 1. And that's a property of exponents. Anything that you raise to the 0 power gives us 1. Okay? Now our last one is 8 raised to what power? Gives us 8. And I hope that you are able to see that that is 8 to the first power equals 8. So our exponent there, our exponent is 1. Okay? So I am hopeful that what you are looking at is you are starting to make those connections between exponent and logs. So the definition, a logarithm is an exponent. So when you are looking at your answer, so right here I have log base a of x equals y. Log base a of x equals y. Look right here, this is my base. So my base always stays the same. Okay. The of portion, this is the answer to an exponent. That's your of. Log base a of x. That of x is the answer when you are dealing with an exponent. And our y is the exponent. So log base a of x equals y. If we are looking at the exponent portion of that, that is the exponent. The log is an exponent. Now you are going to want to be able to go back and forth between a log and an exponent without any hesitation. That is something that you are going to want to do for the entire chapter, is turn a log into an exponent and turn an exponent into a log. So it's very important that we spend some time practicing that. So here we go. We are going to convert each of the following to a logarithmic equation. Okay, so this is our first one. 16 equals 2 to the x power. 16 equals 2 to the x power. It's important to make note that the 2 is the base. So 2 is being raised to the x power. That's our base. In our log, our 2 is also the base. Okay, so then we have log base 2 of 16 equals x. Log base 2 of 16 equals x. Our base stays the same. Our exponent becomes our logarithm. And this 16, that is what we put after our of. Log base 2 of 16. Okay, let's do another one. So here I have 10 raised to the negative third power. Now our exponent can be negative. Our base can't be negative and our answer can't be negative, but our exponent can be negative. It is okay to have a negative exponent. So 10 to the negative 3 equals 0.001. A negative exponent means we are dealing with small numbers. Negative exponent means we are dealing with small numbers. Okay? They are not negative numbers. They are small numbers, like the width of a cell wall. Many of you will be taking chemistry next semester, and a lot of things in chemistry are going to use negative exponents. Okay? So our base is 10, so our base is going to stay the same. So we're going to have log base 10, and be sure you write that slightly down. This is our of. So log base 10 of 1,000th. So 0.001, that's red, 1,000th, and that equals our exponent, which is negative 3. So 10 to the negative 3 equals 1,000th is the same thing as log base 10 of 1,000th equals negative 3. Okay, let's do our next one. Now, e is an irrational number, and as you were looking through your videos this week, you will learn more about e. It's Euler's constant. It's a little bit like pi. It's an irrational number. So here we have e raised to the t power equals 70. Okay, e raised to the t power equals 70. So our base here is e. So this is going to be log base e of 70 equals t. Now, I do want to take just a minute. On your calculator, you may see something called a natural log. So when you are dealing with a natural log just means base e. So I could write log base e of 70 equals t. I could write the natural log of 70 equals t. They mean the same thing. So anytime that you start dealing with base e, you can look at it as the natural log. If there is no number written as your base, so if you just have log of 1,000th equals negative 3, the 10 is the base that is used most often. So if you have just log, you don't have a base written down, the base that you're using is 10. So now I want us to go the other way. I want us to convert some logs to exponents. And so you definitely want to be able to go both directions this chapter. You want to be able to go from exponents to logs and from logs to exponents. So remember, our base is going to stay the same. So here I have log base 2 of 32 equals 5. So our 2 is our base and it stays the same. 5 is the answer to our logarithm, and it is your exponent. So it's 2 to the 5th power equals 32. So log base 2 of 32 equals 5 is the same thing as 2 to the 5th power equals 32. So our next one is log base A. Now, we don't know what base A is, and that's okay. We don't have to. Log base A of Q equals 8. We're just rewriting it. A is our base, so we're going to have A raised to the 8th power equals Q. Log base A of Q equals 8 is the same thing as A to the 8th power equals Q. Okay, and our last one, X equals log base T of M. And it's written the other direction. Okay, so we have X equals log base T of M. Our log is on the right side. Our other two examples, we had log on the left side, but we still treat it the same way. If you need to rewrite it, you can. You can write log base 10 of M equals X. So T is our base, so we are raising T to the X power, and when we raise T to the X power, we get M. Okay? Again, I want you to be sure that you are able to go back and forth. You've got to be able to go from a log to an exponent and from an exponent to a log. So take lots of time practicing that to make sure that you've got it. Okay. Before we go, a couple of things that I want to remind you of. You definitely want to review your properties of exponents. You have an assignment inside my math lab for your Math 093 course, and that's super, super helpful. Also in your Math 093 course, you will be doing a study guide specifically on properties of exponents, and then you will move into properties of logarithms. Okay, the relationships between the properties of exponents and the properties of logs are very, very helpful. There's a relationship there, and you want to be able to identify that and see those relationships. A few things that I want to remind you of. Your test on Chapter 4 needs to be taken by Monday, November 6th. You have a little less than a week. If you are taking that in the testing center, you have to sign up 24 hours in advance. It will show it as full. If you try to sign up less than 24 hours in advance, it won't let you. It'll just say all the slots are full. You have to sign up 24 hours in advance. If you are taking it with an outside proctor, just make sure that you've reminded me who your proctor is and when you were taking it. I have several people taking it tomorrow, November 1st, and that's great. I will send the test to your proctor. If you want to take it in my office, you can take it in my office at 1 p.m. tomorrow, but you have to start it by 1 p.m. You can't start it any later than 1 p.m. The other opportunity to take it in my office is Monday at 10 a.m. on November 6th. Okay, I will be doing my office hours on Halloween, so it's October 31st. That's today. I'm recording this on Halloween. October 31st, I will have my office hours at 7 p.m. We might be dealing with the doorbell because people will be trick-or-treating, but I do want to go ahead and have my office hours because I know some of you need to get in touch with me before you take your test. I'll also have my office hours this afternoon at 3, Wednesday at 2, Thursday at 11. So lots of opportunities for that. So I hope everybody's having a great week. Please don't hesitate to contact me if you have any questions or concerns. Have a great week.